Now let us discuss moment of inertia of composite figures. So the moment of inertia of composite figures, the formula is I is equal to I1 plus I2 plus I3 plus, means we have to add the moment of inertia of all the composite figures, then we will be getting the total moment of inertia. So if they are given like this for composites, means suppose one triangle given, one rectangle given, one semicircle given, then we have to take 1, 2, 3. So you have to add 1, 2, 3 moment of inertias, then you will get the total moment of inertia. Now for example, if the diagram given like this, then let us say inside there is a circular hole. Now including this hole, we have to take it as 1, this as 2. Now these are examples. Now the total moment of inertia is equal to I1. I1 means it includes this hole also. This is the hole. So total is 1 minus 2, means I1 minus I2. Then we will get the moment of inertia for the shaded area. So for shaded area. So depending upon the given diagram, either we have to apply the sum of moment of inertia of all the diagrams, or we have to minus like this if there is any hole inside another diagram. Now let's take a problem on moment of inertia of composite figures. So this is the given problem. Determine moment of inertia of the figure given below about an axis passing through the centroidal x and y axis. The centroidal x means, so this is the centroidal axis, that is y axis, and centroidal x axis is somewhere here. So this is the G. So G is centroid. So what is given? So we have to calculate moment of inertia about centroidal x axis and centroidal y axis. So this is the diagram given. So this length is 150, this is 10, this length is 140, this is 10. So we have to calculate moment of inertia about centroidal x axis and y axis. Let us solve this problem. So first I will draw the diagram once again. So first let us divide this composite figure into known plates. Means by dividing this we will get two rectangles. Let us say this is rectangle 1, rectangle 2. Now the dimensions given. So this dimension is 150. This is 10 mm. And this is 140. This dimension is 10. Now this is 1, so this dimension is B1, this is B1, B2, D2. So the dimensions are B1 is 150, D1 is 10, B2 is 10, D2 is 140. Now let us calculate areas. A1, that is 150 into 10, 1500 mm square. Then A2, 140 into 10, that is 1400 mm square. Now moment of inertia about centroidal x axis. Moment of inertia about centroidal x axis equal to moment of inertia about x axis for rectangle 1 plus moment of inertia about x axis for rectangle 2. Now this is equal to moment of inertia about its center plus A1 H1 square. What is G1? G1 is the center of rectangle 1. Now, so we have to apply parallel axis theorem for Ix1 because the center of complete diagram is different and the center of rectangle 1 is different. So there is some distance between center of rectangle 1 and for the complete T section. So we have to apply parallel axis theorem. So what is this formula? This is parallel axis theorem. So similarly, we have to write for Ix2, that is moment of inertia about center of rectangle 2, let us say G2, plus A2 H2 square. Now this can be written as moment of inertia about centroidal x-axis, that is B1 D1 cube by 12 plus A1 means B1 D1 into H1. So H1 is the distance between its centroid up to the reference value. Means H1 is the distance between center of rectangle 1 up to the center of the complete diagram. So I'll write here H1 is equal to, so this is about x-axis, so we have to take y bar minus y1, perpendicular distance, y bar minus y1, H2, y bar minus y2. So I'll write this H1 as y bar minus y1 whole square plus for the second one B2 D2 cube by 12 plus B2 D2 into y bar minus y2 whole square. So this is the formula for Ix2. Now let us substitute all the values. We know B1, that is 150 into D1 10 cube by 12 plus B1 150 into 10. Now this y bar we have to calculate. So let us calculate y bar. Y bar equal to A1 y1 plus A2 y2. So A1 means it is capital A. So we are taking areas as capital A. So let us make it capital A by A1 plus A2. So to calculate y1, y2, let us take some reference axis x dash. So from this y1, let us calculate y1. So y1 is 5 because this length is y1. You can see in the diagram y1 is 5. Now y2. So from center of second rectangle up to reference axis is y2. So this y2 value we are getting as 10 plus half of this 140. 140 by 2. That is 70 plus 10, 80. So substitute y1, y2, that is y1 is 5, y2 is 80. So substitute areas A1, A2. So substitute A1, y1, A2, y2 by A1 plus A2. This y bar value we are getting as 41.21 mm. So in this y bar is 41.21 minus there is a y1, that is 5 whole square. So this is the first term plus B2 10 into d2, that is 140 cube by 12 plus b2 d2 into y bar 41.21 minus y2 whole square. So this is the moment of inertia about x-axis. So Ixx is equal to, so by calculating all the values, we are getting this Ixx value as 637244.2.5 mm to the power of 4. So this is the moment of inertia about x-axis. Now let us calculate moment of inertia about y-axis. I, y, y. I'll write directly. That is Ig1 plus A1 H1 square plus Ig2 plus A2 H2 square. This can be written as d1 b1 cube by 12. Now in this you can see the given diagram is a symmetric about y-axis. So the given diagram is symmetric about y-axis. Given figure symmetric about y-axis. So this value will be 0 and this value will be 0. So about centroidal y-axis, we know formula, that is d1 b1 cube by 12 about its center plus d2 b2 cube by 12. So let us substitute the values. d1 is 10, b1 is 150 by 12 plus d2 is 140 into b2 10 cube by 12. Just substitute all the values. By simplification, we are getting moment of inertia about yy as 2824,166.7 mm power 4. So this is the moment of inertia about y-axis. These are the required answers. This is the first answer and it is the second answer. So this is the given diagram. You have to calculate moment of inertia about centroidal x, centroidal y. So this is the moment of inertia about centroidal x, Ixx, g. This is the moment of inertia about centroidal y axis. So for about x-axis, we have to apply parallax theorem because center of rectangle 1 is different, center of complete diagram is different. For the rectangle to center, for the complete diagram center is different. So we have to apply parallax theorem for two rectangles. Now coming to moment of inertia about y, it is passing through the centroidal y-axis. This y is passing through the center of the t section. So directly you can use centroid formula about y, db cube by 12 for rectangle 1, db cube by 12 for rectangle 2, we will get answer. So this is the moment of inertia. With this problem is complete.